Hello everyone, in this video we're gonna learn how to graph the inverse trigonometric function. Alright, first we're gonna talk about the sine function, right? So y equals sine s. Now we know that the domain of the sine function is going to be all real numbers, and the range should be -1 to 1, right? Now, look at the unit circle right here. The sine function represents the y-axis, right? Right here is 1. Right here is -1, right? So minimum -1, maximum is +1, right? Now, you know that the period of the sine function is going to be 2 pi, right? So you're going to divide 2 pi into 4 quarters, right? So 2 pi divided by 4 is going to be pi over 2. So each quarter you have pi over 2, right? So the periods right here. Alright, so this is 1 quarter, this is 2 quarter, this is 3 quarter, right? Now this is 1, this is -1, right? This is maximum and minimum, right? Now you know that the sine function always starts at origin, right? So this right here, right? So it's go up to maximum, right? Maximum in the first quarter, right? And then go back to the midline, right? And then go down to the minimum in the third quarter, right? You look at this one, it starts right here, go to the maximum right here, this is the first quarter, go to the midline right here, and then go down to the minimum right here, and go back to the midline right here, right? The midline right here. Alright, so you just connect this guy. Alright, so then if you copy this one to the left hand side, so it's gonna be like this. Alright, so now we're gonna sketch the inverse function of sine of s, right? So inverse function will be denoted as y equals sine inverse of s, like this. So we will read this one as sine inverse of s, right? Now keep in mind, this is not 1 over sine s, right? So be careful, this is not the case. Or you can write this one as arcsin of s. Alright, so they're both the same. This way or this way, they're popular, right? But don't write like this. If this guy is the inverse of this guy, and then domain and range will be switched, right? So the domain of this one is -1 to 1, right? And the range, this is domain, the range, it should be all real numbers, right? So keep that in mind, you learned that one in the first semester, right? Now, this point right here, pi over 2, 1, becomes 1 pi over 2, right? So keep it right here. Now this guy right here, pi 0 becomes 0 pi, so keep it right here, right? Now this guy right here, 3 pi over 2, -1 becomes -1, 3 pi over 2, right? So it's gonna be right here. And this point right here, 2 pi, 0 becomes 0, 2 pi, so keep it right here, right? So if you connect this guy, it's gonna be like this. Alright, now this guy right here, -pi over 2, -1 becomes -1, -pi over 2, so it could be right here, right? This guy, -pi 0 becomes 0, -pi, it could be right here. This point, -3 pi over 2, 1 becomes 1, -3 pi over 2, right? So it could be right here. negative 2 pi, 0 becomes 0, negative 2 pi, so keep it right here, right? And then you just connect this point. Alright, now of course, the inverse right here is not a function because it does not pass the vertical line test, right? This guy does not pass the horizontal line test because when you draw a horizontal line, it intersects the graph more than 1 point, right? So it does not have the inverse function, right? So in order for the function y equals sin s has an inverse function, we need to restrict the domain, right? So how do we restrict the domain? So we look at this one right here. From here to here, we're gonna restrict the domain from negative pi over 2 to pi over 2, right? So it's gonna be this guy only, right, within this interval. So within this interval, the function will have the inverse function, right? So it turns out to be negative pi over 2 to pi over 2, right? So it should be this guy right here. Alright, so in this situation, this guy does pass the vertical line test, so it's the function. This guy passed the horizontal line test, so you just erase this guy. Alright, so this is how we restrict the domain of the sine function so that its inverse is also a function. Alright, so keep that in mind. Now on the unit circle, how do we know it? We know that the highest point right here, 1, right? It's actually pi over 2 right here, right? The lowest point is negative 1. This is actually negative pi over 2, right? Alright, so this is the best way for you to memorize. So it should be these regions right here is the restricted domain of the sine function. The quadrant number 1 and quadrant number 4. Alright, so keep that in mind. Now next one, we're going to talk about the cosine function. Alright, so the domain of the cosine function is going to be all real numbers, right? The range of the cosine function is going to be negative 1 to 1, right? This one is 1. This one is negative 1. Now, you know that the period of the cosine function is going to be 2 pi, right? Alright, so we're going to divide 2 pi into 4 quarters. Each quarter has pi over 2, right? So this one is 2 pi, right? Each quarter is pi over 2, another pi over 2, and another pi over 2, right? Now you know that the cosine function always starts at the maximum values on the y-axis, so it could be right here, right? Now the x-axis represents the cosine function, right? So this is the maximum value, right? When the terminal rate and the initial rate overlapping, right? It's gonna be 1, right? When it's go over here, you project down to the x-axis, it's gonna be 0, right? So this right here, it's gonna be pi over 2, right? So at pi over 2, the cosine function go back to the midline, right? Next one is go down to the minimum right here, right at pi, right? Because this guy right here is pi, cosine of pi equals negative 1, right? Negative 1, so negative 1 right here. And then right at this point, it's go back to the midline, right? Remember, the midline should be this one. So keep that in mind, alright? So let's go back to the midline right here. And then when it completes a full cycle, it's go back to the maximum, right? So the maximum should be right here, 2 pi, right? 2 pi, which means one value, right? This could be right here. And then you just connect this one, and then you get the cosine function. Alright, now if you duplicate this one to the left hand side, and then you get the points right here, the points right here, right here, and then right here, right? So you just connect this one. Alright, now we're gonna graph the inverse of this function, right? So the point 0, 1 becomes 1, 0, right? So it could be right here. The point pi over 2, 0 becomes 0 pi over 2, so it could be right here. The points pi negative 1 becomes negative 1 and pi, right? So it's gonna be right here. The points 3 pi over 2, 0 becomes 0, 3 pi over 2. So it should be right here. And the point 2 pi 1 becomes 1, 2 pi, right? So it's going to be right here. Now you just connect this one. Alright, so this is the cosine inverse, right? Now if you duplicate this one, it should be something like this. Alright, now of course this is not a function because it does not pass the vertical line test, right? Similarly, the original function cosine right here does not pass the horizontal line test, so it does not have the inverse function. So in order to get the inverse function, we need to restrict the domain, right? So the domain will be restricted from 0 to pi. And then its inverse should be this one, right? Now on the unit circle, the restricted domain of the cosine function should be this guy, upper half circle, right? Now, since the cosine function has the domain all real numbers and the range is to be negative 1 to 1, and then the inverse of this one, y equals cosine inverse of this r, y equals r cosine of s right here. Alright, they both the same, but you cannot write like this 1 over cosine s, right? So this is wrong, right? Now the domain becomes the range and the range becomes the domain. Now keep in mind the restricted domain in this situation, it should be 0 to pi, right? To summarize the domain and range of the sine and cosine function as well as its inverse function, we have the following information. The restricted domain of the sine function should be the closed interval negative pi over 2 to pi over 2, right? And the range should be closed interval negative 1 to 1, right? The inverse sine function has the domain negative 1 to 1, and the range should be negative pi over 2 and pi over 2, right? Keep that in mind, you just switch s and y, right? Alright, the cosine function has the restricted domain. It's gonna be closed interval 0 to pi, right? The range should be negative 1 to 1. And then the cosine inverse of s has the domain negative 1 to 1. And the range should be closed interval 0 to pi. Alright, so keep that in mind. Now let's move on to the next one, the tangent function, right? So y equals tangent of s. We know that the domain of the tangent function is going to be all real numbers except the vertical asymptote, right? So keep that in mind. The range should be all real numbers. We know that the tangent function is undefined as pi over 2 plus k pi, right? So basically, we need to draw the vertical asymptote, right? Alright, Now, the tangent function always pass the origin, right? And then we need to find the other 2 points right here. So it's going to be somewhere right here and right here, right? And then it's going to be something like this. Now, in order for the inverse of the tangent function to be a function, we need to restrict the domain, right? So the restricted domain of the tangent function should be from negative pi over 2 to pi over 2. But we're not going to include the vertical asymptote because right at these two vertical asymptotes, the tangent function is undefined, right? So we should have the open parenthesis right here. So negative pi over 2 to pi over 2, right? So it should be open interval, right? The range of this one still are real numbers, right? So the inverse should be y equals tangent inverse of s, or we just write tangent of s, right? But we're not gonna write 1 over tangent s, right? So this is completely wrong, alright? So the domain in this situation should be all real numbers, right? And the range should be negative pi over 2 to pi over 2, right? Now, 2 vertical asymptotes becomes 2 horizontal asymptotes, right? So it could be right here. And then if you graph it, it's going to be something like this. Now remember that the restricted domain of the tangent function has the same things as the sine function. So it's going to be from negative pi over 2 to pi over 2, which is the first and the fourth quadrant right here. Now let's use a calculator to graph sine and sine inverse, cosine and cosine inverse, tangent and tangent inverse. Now we're going to hit Control I, hit Add Graph. Now we're going to hit Trig. We put sine as, we hit Enter. It's going to be right here. Now we're going to hit Tab. We put Trig. We put sine inverse of s, hit enter, it's going to be the rest one, right? Now let's start the new graph for the cosine function. So you need to hit the Control I, add graphs. Alright, so you're going to hit Trig cosine of s, hit enter, it's going to be like this. And then hit Tab, hit Trig cosine inverse of s, is going to be like this. Alright, now we're going to start the new graph for the tangent function. So you're going to hit Control I, hit Add Graph. So you're going to start with Trig tangent right here, ask, hit enter, and then hit tab, Trig tangent inverse of ask, hit enter. It's gonna be like that, right? Now, what if we use the TI-84 plus C calculator? We just print it up. Alright, so it's gonna be similar than TI and SPY calculator, right? First, you need to adjust the mode, right? So you need to hit mode right here. It should be radian. Keep that in mind. Always radian, not degree, okay? So hit second, quit. Alright, so you're gonna hit y equals right here. You need to clear it. This one you need to clear it. Right, so you're gonna hit sine, ask, close parenthesis, hit graph. It's gonna be like this. Alright, now hit y equals the second one right here. You put sine inverse, so it can hit second sine of s like this, and hit graph. And you see that it should be right here, but because this guy and this guy have the same color, so you need to change the color. Alright, so you go over here and you hit enter, change the color to red or yellow. Okay, hit enter. Okay, now hit graph and you will see it's right here. Alright, now if you want to see this one clear, you need to hit the window. You adjust the window. I just put cosine, right? And right here I put cosine inverse, right? So second cosine inverse and hit graph, it's gonna be like this. Alright, now you want to see this one clear, you need to extend the positive y-axis, right? So you hit window, positive y-axis right here, you just put line 4, hit graph, it's right here, right? Now let's move on to the last one, hit y equals. Now you need to hit tangent, right? And then for this one, you need to hit second tangent and hit graph, it's gonna be like this, right? And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals, they take us higher. The night's young and it's just begun as she puts her hand in mine.